Hello, today I'm going to show you how to take some of the other videos that I've made and combine them into one project. This project is essentially a learning remote. What we have here is an IR receive LED. Back here we have an IR transmit LED. Here we have an LCD display that's I2C with a backpack module to convert it. And then lastly we have a SD card shield here that records all the key commands for all the keys on the button, and then also when it plays it back reads from the SD card to play on the TV. So let's see how all this works in real time. So we hit reset here and this is all going to flash, and so we have two options: one, play mode; two, learn mode. So let's start with play mode. We hit 1 and enter, and it asks us, it first states that it's play mode, and then it says choose A through X. Well, I know A is power, so I hit A and enter, and it issues a power command. It reads the hex code from the card and then plays it, and the TV comes on. Let's try play mode again. Enter. And this time we're going to do the letter N, which is an offset in the SD card, which is going to be mute. And if we hit enter there, it says mute and the TV muted. So let's try that again. 1, play mode, and enter, and the mute goes off. So that's how it plays. It's actually reading from the SD card. The second half of this, which it says here 2 for learn mode, we do 2, and we hit enter. And now it's asking us our first read, and we're going to do 2 reads where we get 2 hex numbers like this in a row that are the same. Until we do that, we don't have a good read. So let's first do the power button. And I have this tube around the infrared receiver to keep out all the other ambient light so we get a good read as soon as possible. So if we do this, there's read number 1, read number 2. It says good read. It then writes it to the card, and that was the code 40BE629D for power, and that's actually correct. So let's try, now it's asking us for read number 1 for button number 1. And like I said, I go through all of these buttons. It takes a while. So let's do button number 1, and let's press 1. And now it's saying read number 2. And let's do a different button. Let's do mute. And it says read error. Press number. Now we're going back to read 1 again. Read 1, read 2, good read. Now we go on to button number 2, and then we go 3, 4, 5, all through 0, volume up, volume down, source, all of these, and pretty soon you have all the key codes of the remote stored on the card, ready for play mode. So that being said, let me show you how the code handles all of these different devices with different pinouts and that sort of thing. I'm going to show a cutaway at the end of the video for the wiring schematic here. I also have a cutaway showing the top view of the wiring. It isn't really terribly complicated, but certain pins have to be used for certain things for it to actually work. But I will give more in-depth discussion when I show the close-up of the code. So here we are with the code, and I want to go through it line by line and show you what I did to get all those different modules working. There's a few things to keep in mind though with this actual hardware situation. One thing to keep in mind is the IR LED that receives is very sensitive to random interference from outside light. So you have to put it in a tube if you really want to get a good reading. Also, the SD card with the IR must use 5 volts. You need it, so you're going to basically have 2 sets of voltages running with these devices, with these modules. Some are going to run at 3.3 volts. Some are going to run at 5. So you're going to have to supply 2 different power inputs. Something to keep in mind also is the Mega, in this case, must use pin 9 for the IR transmit, and pin 11 for the RX. Receive. If you switch the pins, won't work. I do a power exponential function here to calculate the hexadecimal value that is read to the IR transmit to turn the TV on or mute it. And it turns out, I found out that there's no FPU, floating point unit, in accounted for on the Mega or the Uno. So it does kind of a software, I guess, bit shift or something, calculation, and sometimes the calculations do not come out right. So I did find a way that it actually works consistently, and I'll show you that. It's very odd, but I was able, that was a big hurdle. I could not get the IR code to calculate out so I could retransmit it, because I store the code as a character on the card, and I read it back and then convert it to a number and then send it out. So that was tricky. So the IR receive has some issues. So very often it will get misinformation and get the wrong hex code. So what I do is I do multiple reads from the remote when I'm training it, and I store the first two that are equal. And I'll show you that in the code. And that actually saved me a lot of errors. So if you turn it on, you go into record mode, and it somehow has some sort of fluky, receive some sort of invalid data, you then come back and do it 2 more times in a row, and that usually corrects it so that you get the right code written to the SD card, because that's critical that you get that written correctly. And I think that's just about it. Those were the tricky things to keep in mind that kind of slowed me down. So let's go look at the code here, and you'll see that I start off, I initialize the IR, I include the IR remote library. I set the IR receive pin to 11. I then come down through here and initialize some variables. I give the IR receive, this variable here, IR receive pin, which is 11. Some results for decoding, and then IR send pin is number 9. So once that's set up, I come down here, and these variables here are used to convert characters of the hex code command stored on the SD card, then convert them from a characters to a decimal. Next, raise to a power for each character, lastly storing a running total in the total decode number, and finally printing it as a hex number, matching the command stored on the SD card. Each command is stored on the card at a seek offset of 10. So let me recount what this is actually doing here, and this is the initialization for doing that conversion. Once you read a character from the card, and I think that's what this is right here. Yeah, stored on the SD card. You have to. I read them back character by character, starting from the left, so it's the most significant digit, and I store them in data input. And then I use get character to get the next character. And what I do is I read all the characters, that 40BE, and then the last 4 digits. All of them are going to start with 40BE. That's the NEC header. But the last 4 are going to be the power button, the mute button, whatever they are. But I read them character by character using this, and then I convert them. Right here using character to int, and then I take that integer and I multiply it to the power of like 7, 6, 5, 4, 3, 2, 1, 0 as I pull off each hex character. So the very first character, let me give you an example here. The very first character, let's say 40BE, that'd be capital B, BE 357A. Well, the very first character here, the 4, you will basically multiply that by 16 to the power, and I think that's an up arrow, to the power of 7. Here it is. shift up arrow 7. That's basically what it is, which is 4 raised to times 16 to the power of 7. And then so 0 would be the same thing. It would be 0 times 16 to the power of 6. And then B is B, and then you have to also convert the hex B to really, what is that? That's really 11, right? So it's 0 through 9, A is 10, B is 11. So that's really 11 times 16. 11 times 16 to the 5th power, and so on for each of these. So you basically have to take off each number as a character, convert it to a number, an int, multiply that by the power of its position in the string. So 4 is the first one on the left, the most significant, so it's to the 7th, 6th, 5, 4, 3, 2, 1, and then 0, and 0 is just 1 of to the power. So once you calculate that all out, it will be the hex digit that you need to send to the TV. And that was really complicated, but I've solved it here, making it easy for everyone to use. So let's scroll on down, and I'll show you in the code actually how that works. So there are so many modules here that we need different libraries. So here's the data card here, the SC card. And here's the header, here's the library for it, and we have a chip select of 53, the file, which we open up on the card to save the commands. And this is an index used in the seek. And what I did was, in the seek, I basically put the first button goes at position 0, the next button goes to position 10, offset, the next position goes to position 20, offset, and so you just keep going. And if you have 23 buttons, you're offset 230 bits from, or location characters from the inside of the file. Now you're only saving 8, so if you offset 10, you've got 2 spaces in between the characters. For instance, let me just show you here, this offset right here. Let me go here. So if you have an offset, if you have the first character is 40 BE 768A, and then it's 40 BE 883C, and so on and so on. So basically this would be the power, this would be button number 1, so on and so forth for all the buttons. And so you go to the offset as 0, and that's what this is. It starts out at 0, and then you add 10, you're now reading here. You add 10, you're now reading here, and so on and so on. You're reading all the characters until you reach the very last character, or the very last set of hex digits. So that's why you need an offset to store. I mean, I guess you could, theoretically, you could have these right next to each other, but it made it harder to read when I came back to verify if the card was being written correctly. This was a lot easier to read, so I could tell, am I getting the right code on the screen? Is it being written in the right position? It just made it a whole lot easier for me. You can do whatever you wish. You don't absolutely need to have this offset. You will need to have the offset. If you have it like this, you will need to have the offset come in. If you want to read just this code, you'll have to make sure that you don't accidentally get this code. So I left some spaces because you can always test for a space if you need to. I didn't need to. It worked very well. So here we have the libraries for the LCD display. It's the wire library. This library allows you to communicate with I2C. That was the LCD. I put the LCD in because eventually I'd like to be able to do this autonomously without the PC at all. And it talks about here the pins that need to be set up in the board and everything else. I've discussed this in another video. These are all the different libraries you need to include. And then here you define the address for your LCD screen. And then here's the how it actually displays it using I2C. You don't have to use I2C. I just use it because it only uses 2 pins. And then I claim a button option and mode option, which I use for deciding what button's being pushed or what mode. Are we play mode or learn mode? And here's the setup. We set up the serial begin, pin mode 13. This is part of the IR receive function, and I said I was going to remove it, but I didn't remove it. I left it in. The IR send pin is output, and IR send pin is set to high. I start the IR receiver here, and this bit of code here is actually critical. You'll wind up using it later in a function IR. The send function I think I have down below. You need to issue this twice, because if you don't issue this twice, the IR receiver doesn't work after you do a play mode. So if you start up the sketch and you do a learn mode first, it'll work, and then you do your play mode, it'll work. But if you go back to do the learn mode, it won't. So you need to have this down there in your learn mode. So anyway, here we set up the LCD screen, we clear it, position the words. We have, this is the CS pen, the chip select pin for output. This is for debugging. I delay a little bit to let it do its thing. This is just kind of writing some stuff to the screen, to the LCD screen. This is something that isn't required here. I use this to fill up the command file with 200 blanks to kind of initialize it. You don't really need to do that, so I left it out. Here I say initialization is complete, and here we have some IR codes, old and new. This is for debugging. This is actually for debugging in case you get a bad read from that IR receive in that cone. If you decide to do learn mode and somehow it gets some sporadic data, I store it in old, and then I read the new, and then I compare the two, and if they match twice, I say it's a good read, unless if they don't match twice in a row, it's a bad read, and you keep reading it until you get 2 in a row. And that's actually not too difficult to do, to get 2 in a row. It happens pretty quick. But you do get sporadic data, and it saves you going back to the SD card and reformatting it and doing all that crap again. Going through and having to clean up the mess it made. So here we play mode. We list this on the screen: play mode, learn mode. I do the F command because that allows you to save space in SRAM and stores it basically in your primary memory. And there's tons of primary memory on a Mega. I think it's 300K, and you only have like 8K of SRAM. So I try to minimize using the SRAM as much as possible. We echo the same information on the LCD screen, and then we wait here, wait for keyboard input, and then we read the mode option. There's only 2. It's either one for play, 2 for learn. And then I convert it to a decimal here, whatever mode, whether it's 1 or 2. Basically, you're subtracting a 0 here. 48 is ASCII 0. And then if it's mode number 1, then this is an ASCII digit between 0 and 9, play mode. We display it on the screen. We choose a button, A through X. We set the position, and we say on row number 2, choose A through X. And initialize the keyboard input button option. We want to know what button we choose, what letter. And we wait for the keyboard input for the second menu, A through X, and read the button option. And we switch on that button option. If we get an A, it's power. Turn the power on. It prints power on the LCD. We do a file offset 0 because that's where the power button is set on the SD card at offset 0. And then we do the send code. And I'll show you where the send code is down below. And it's the same thing for each and every button, A through X. A through X represents every button on the remote, and that you're just playing it. So here's B. I echo number 1. You press number 1. File offset is 10 because that's where it's stored. We do the send code, and then we break out. And we keep doing that for number 2, 3, button 4, 8, volume up, volume down, mute, channel up, channel down, arrow, return, OK, exit, and then source is the last one. And that's at offset 230. So there's basically 23 buttons or 24 buttons. Now let's go look at send code. We go down here, we'll skip through this, we'll come back up. Send code is, let's see, here's send code. And I write this flag out for debug saying we're now reading from the file. It goes to the SD card. We reset the decoded number. We reset the character number, and we say the total decode number is 0. So because we have to loop through it 8 times. The file we're opening is commands.txt. That's the same one. Make sure this is 1, 2, 3, 4, 5, 6, 7, 8 characters, no more than 8. And in this case, it's a txt file open for reading. We give it a little bit of time. We do my file seek. We do the offset. In this case, for power button is going to be 0. And then we do an int I from 1 to less than 9, which is 8. And so we're getting 8 characters. The first character, we do a read. We delay it to give it some time because we're reading from the card. And then this is what's interesting. Here's the power function. The first digit we get from the card is going to be a B, the letter B, because the code is B0. Remember here, maybe I should put this here. The code is B0 for, I think, C. And then it's a bunch of 4 digits. That's for, this is for, this represents, oh, actually, I don't think it's C. I think it's E. This is the code for an NEC remote. And then the back half of this, the 4 digits, 4, 5, Able, Charlie, is the, say, the power button. And then there's different buttons. So we have to pull off just this B, and that's what this does. So we start out with the power of 8 minus I. And since I is 1, it'll be power equals 7. And I had some problems with this. So what I do is if the character that we read, get character, is between 0 and 9, we say the character the number is that character minus 48 because it's numeric, 0 through 9. Then you have to skip a couple digits. Otherwise, if the character is 65 and between 65 and 70, which is A through F, then you have to subtract a 55, which is a different offset to convert the character A to a 10, or the C to a 13, or 12 to a 12, and a B to 11, and an E to a 14. So for numbers 0 through 9, you use this if statement, and letters A through F, you use this statement. And then I had a problem. I tried to do this power 8 minus I, and I tried to put that power 16 comma 8 minus I here, and it would calculate the power wrong, and it kept doing it over and over. So I just said, screw it. I will make a case statement depending on what power is. So in this case, power is going to be 7 because we're doing our first loop. We're getting our first character, and 8 minus 1 is 7. So for a power, we go down here to case 7 right here. Oh, let's get back up a little bit. Maybe I shouldn't do that way. And what we do is we say decoded number is equal to the character int, which is, in this case, if it's B, which I had up here somewhere, a B, that is 11. So 11 times the power raised of 16 to the 7th. And that gives you the highest significant bits decimal value. And what I do is I store that in decode number. Then I go back, and this is the N4, so I go back up to the 4 statement up here. And right here, for I equals what? Now I is going to be 2. And so 8 minus 2 is 6. We're reading that character, which is a 0. We go down to power of 6. Decode number equals character int 6 plus 16 to the 6. Well, character int is a 0. And 0 times anything is going to be 0. So basically, we then say total decoded number is the old total plus the new decoded number. So I store all the powers ranging from 8 all the way down to 0 in this value right here, which is a long, not floating point, but it's a long integer. And so we get the full 32 bits stored here. And what I do then is we then go down here and we close the file once we've decoded all of these bits. Once we've decoded all of these and stored them as a numeric value here, we come down and we close the file on this SD card, we delay to give it some time, we print a space, and then we send the, now in this case I know my remote is an NEC, I send that code because it's already I think I convert it to a hex somewhere, as a 32-bit as the power code. And that turns on the power to the TV. I now print this because the TV doesn't know if it's hex or not hex. It just wants the number, this number here, sent to it. And you can send it binary, you can send it decimal, you can send it hex, it doesn't matter. At least that's what I found. It worked for me. What I did here was I printed it to the screen in the hex number that I was expecting. That way I know that I got the right value. And then that's the end of the send code, which is the end of this portion way up here. That's the end of play mode, where play mode basically sends the code that you choose depending on the file offset that you send and the option you choose from the A through X menu. And then it goes back to the menu and it says, what do you want to do, play mode or learn mode? Well, let's do learn mode. We go down here. If you don't choose play mode, you must have chose learn mode, and that's why we have learn mode here. We clear everything. The IR code old is set to 0, IR code new is set to 1. You just make sure these two are different because you're going to compare them. So I just put anything in there. And then I say, please press the power button, because now you're teaching the remote. You're storing the remote codes to the SD card. So now the first one you want to do is press the power button. You could press the volume up, it wouldn't know, but it's going to say that that's the power and think that that's the power. So make sure you press the right button. So basically you set up the LCD, you go into read code function right here. I write to file. So there's two portions here. One portion is reading the code, and then the other portion is writing it to the disk, because you got to make sure it learns it. So and then that's true for press the power, press the number 1, and you have to go through all of these. Once you start it, it's going to take you through all of them. You can do a reset and not save it and not change any of these as long as you don't press any of the buttons, or it doesn't do a write file. So that's kind of helpful, but it's meticulous. You got to go through one after another for all the buttons. So you'll see here's number 4, here's number 7, we go down, number 0, we go down, here's channel up, and you just have to enter all of these. There's like 23 or 24 of them, arrow down, arrow right, return. I did add source on there recently. So if we look at that, it's at it, and I said that X is at offset 23. That's the offset position. And so the first thing we do is we read the code, and we need to read the code from the remote. And so how do we read the code? We go down here, and here's read code. Read code. This is the command I told you about right here. Start the IR receive. This is required, else the IR receive will not read remote codes after you do the play mode, because now I'm not sure, there's some sort of miscommunication. I'm not sure how it works, but with the play mode, you've already set up the IR enabled IRN, but then it does some stuff, and the enabled IRN is no longer enabled, and it doesn't work when you go to do the power mode, and you start thinking, did a wire come loose? Is there not receiving? Something goes. So you put this in, and then that solves the problem right there. It all works fine. So I have a do statement here. Here's set up the LCD screen, and while you wait for input 1, and then I echo on the screen. Read number 1, and it's waiting for you to press a button. And then once you read the code, you put that in results value, and then the IR code old becomes the IR code that you just read, because you got to compare them. And code received, so it doesn't know if it's good or bad. And then I print that out so I see what the code was, because then I can kind of tell right away if it's going to work. I wait a little bit to give it some time to be detected, and then I do an IRC resume, receive the next value, and then I print out on the LCD screen again, read number 2, and I wait for the input, just like above, and I get the IR code, and I put that value in IR code. I put the results in the IR code, and then IR code new is equal to that code, and I say code received, and I say what it is, I wait a little bit, and then I get ready to receive another one, and then I say right here, this is where you check. If IR code old does not equal IR code new, then you have an error. They have to equal. The old and the new have to equal. Try again, and then you go back, and you keep doing it until you get 2 in a row. Once you get 2 in a row, you're done with this while statement right here, because it'll keep going and doing read 1, read 2, read 1, read 2. It'll keep going back and forth until you get 2 in a row. Once you get 2 in a row, you're done. Here it says compare the 2 inputs, must be equal, else try again. And you do this over and over until this is part of the do while. This do while. Here's the while. The do is up there. It'll keep repeating all of this code until you get 2 in a row that equal. If they do equal, you blow out of this, you clear it, you say good read, you wait a little bit to give it some time to catch up, and then you go back up to the loop here. We did the read code. I then write to file, because that's what we're doing. And then you go to write to file, because now you've got a good code. You've got a good read from the remote. And that is stored, whoops, I went too far. That is stored in, I believe that is stored in IR code new or old. I gotta look here. So then here's write to file. And I say we're writing to the file. You open the commands file, you wait. If it doesn't exist, you say it doesn't exist. There's a problem with writing, so you gotta make sure. You do a file seek, and this seek for each code has a unique seek offset. In this case, I pass a let's see, going back up here, right here. Here's the seek offset 230. Sorry for the jumping around. And I write the file, I open it, if there's not an error, I seek to that position, and then I print IR code. So if IR code old, IR code new, they all equal the same damn thing, I just use IR code. I print it so that I can see the hex value being printed, and close my file, and I print to my file right here. This is what I'm printing to the SD card, is the actual code. I close it, I wait a little bit, and then that's it of the function write file. And then we go back up here, and that's fundamentally all the code, I believe, if we go way up here, for the learning mode. So there's only 2 modes. I didn't do a whole lot. So basically you read it, you have the offset, you read it, and then you write that code at this offset, and you come back, and then you do that for each and every button that you have on your remote. And then once it's all done, you go back up to the top, and you say play mode or learn mode. Right here, play mode, or right here. Enter 1 for play mode, 2 for learn mode, and that's it. And that's basically what everything does. As far as how you play it back, how you read from the card, some of the problems I had. All in all, it was a little tricky, but not too bad. The wiring wasn't too bad. I have a complete schematic of the wiring. You are, again, keep in mind, using 2 different voltages for different things. The LCD wants one, and the SD wants another, and the IRs require something else. But this will get you started on creating a learning remote which utilizes a lot of the other videos that I've created, and it's kind of one big project. So I hope that this helps you guys with some of these projects to kind of use them collectively and make a bigger project. Feel free to look at the code. If you have any questions, you can email me, but you're going to have to send me your actual email address, unfortunately, because I can't reply through YouTube. It doesn't work. Please subscribe, leave a comment, and subscribe to my channel. If you would, I appreciate that. And I hope to have some other videos up shortly. If you have any other questions, feel free to ask or post a comment. So I hope this helps. Take care.